And hello, hello, hello. Hopefully you can see this because according to Twitch, I'm offline. So give us a shout out if you can hear me. It said I was live, but I'm offline. So we'll see what happens. Yes, I am late. Sorry, Rosso. Oh, I'm guessing. Yes, I'm live. Good, but I can't see my stream preview. Never mind. Okay. Yes, good. So yeah, hello to, as usual, let's see who's usually here. We've got Standard In, we've got Bixie, we've got Yoni Simeon, the Yoni Monkey. We've got myself, Gruffler, Alta, Rosso, hello. Yes, good. Oh, that was me hitting my mouse. You can tell I'm very well rehearsed and practiced at all of this now. Trousers79, very good. Right, what are we doing? Right, I've not been on for a few weeks. All of you will have seen the conversation and probably know anyway. I've not been very well. You know this annoying cough that I've been having for, well, basically the last 4 months? Well, it turns out I had a nasty chest infection, even though I thought it was my stomach because that's what the doctor told me. It turned out it wasn't, and a couple of weeks ago it turned into something quite nasty. I've had pills, I've been drugged, I'm over it, although I've still got a little bit of a cough, and no doubt talking tonight will get some of that out. Pliskit, hello, yes, good evening. But, needless to say, I have not just been sat around watching Netflix for hours and hours and hours and hours and hours on the couch. I have actually been doing some coding too. Alex, hello. It's okay, Rosso. I mean, they gave me some antibiotics and some paracetamol. And I'll say to our American viewers, they were free antibiotics and paracetamol. Kind of. So, anyway, yes, what have I been doing? You may remember last time we finished with an application I can't show because I've butchered the code since, where we were talking about polymorphs. And this is the idea that I wanted to have some basic animatable type of polygon in our editor that we're making. And to sort of facilitate the debugging and testing of these, I created a standalone application just to get rid of all of the clutter and to try and reduce the compile times whilst we're testing this part. And this was the code, and what we did, we created a basic vertex type, and we had a polygon, which was a collection of these vertices, and we'll come back to some of these other bits and pieces later on. And we had the idea of a keyframe and a keyframe sequence. Now, I'm just going to jump into OneNote, so make sure I've got my OneNote pen. There it is. Oh, hello. Yep, OneNote. Now, dazzle everybody. How is my health now? I'm much better now, thank you, Alex. What we did originally was something like this. We wanted to have a polygon that consisted of vertices, and these vertices we would sort of snapshot keyframes of them, and each keyframe would consist of all of these vertices and a duration, and we would store all of these polygon frames in a vector. So we would have, what was it? So a sort of vector of polygon tile keyframes. Now, there's a problem here. It actually works quite well. It's simple, it's elegant, and by knowing the duration of the keyframe, we could sort of work out when we said to the whole polymorph, give me your polygon at this point in time, what we would go away and do is interrogate the keyframe's duration, and we would repeatedly accumulate these, so with a plus, until we got to the time that we wanted, and that way we could work out which particular keyframe in the vector we wanted at that moment. We could take the keyframe and its neighbouring keyframe and then do some sort of interpolation between the two. And it occurred to me, not sort of revolutionary, but that's actually not a great way to do things. It is simple and elegant, but if you had, say, 1 to 200 keyframes in a particularly complicated sequence, then you're spending most of your time repeatedly adding up and accumulating to work out which particular keyframe you want. Thank you, Speedy, and hello, yes. Thank you. This is undesirable because it's in a game situation, you're potentially going to be interrogating these things 60 frames a second, maybe even more. So I wanted to come up with a better way. Now, is there a better way? Well, there happens to be a better way. And that is to try and reduce the complexity of the search for a specific keyframe. in the vector. And to do this, I've decided to move away from vectors and use a fundamental built-in C++ type, as the title of this stream gives away, map. And what I'm doing is I am mapping doubles to a particular keyframe. Am I going to run out of space? I'm going to have to go underneath my... There we go. So this mapping, firstly, you might think, oh no, wow, this is a really complicated data structure. And it is, you know, it's quite a sophisticated one, a map. Why is it not an unordered map? Well, it's quite important that the keyframes are actually stored in order, because I'm storing them with the time signatures. So this allows me to have quite a strange syntax. So let's say I have a map, all of this above, let's call it map of frames. You know my Hungarian notation style by now. What I can actually do now is just directly specify I want the 0.75 seconds into a sequence. This is the data I want to have access to. I'll have a look at this in code. And so I can then interrogate sort of the keys and the values to do the interpolation as well. Now, the advantage of the search here is, of course, it uses a hash map to search. Well, it can do. Depends, I guess, what it decides is the most optimal for this particular implementation. But that means that the search can be somewhat logarithmic rather than linear, which can actually buy us some performance. Oh, Channel, hello, I didn't see you there. Hello. So, whereas it looks like we're going to be making things more complicated using this map, actually we're buying in a lot of simplification. In fact, we're going to let the standard library do the hard work for us, which is the whole point of it. We should be doing that. Now, that's a rather clumsy explanation. It's probably easier to go and have a look at what's going on in code first. So none of this changed. So the keyframe stays the same. In fact, you'll see I've taken out all mention of the phrase duration. It doesn't exist anymore because the key in the keyframe is its time, its location within the map. And here is the map itself. There we go. A standard map of double and keyframe. Now, we decided to be clever last time and make keyframes somewhat data ambiguous, which allows us to then interpolate all sorts of things sort of automagically later on. Same thing with our keyframe sequence. The keyframe sequence has to have at least one entry. That's just to stop sort of awkward divide by zeros. And you can see that I'm replacing at time 0 a single keyframe. Now, it may be that we don't have any animation at all, but we need to have this keyframe in existence at time 0 because that's going to be our default sort of interrogation. Yes, sorry, Yoni Simeon. Double represents time. I could use the Chrono library. I think people know I'm not a big fan of the Chrono library because of its wordiness, but also it just saves having to mess about with sort of translating to and from the Chrono library. It double represents time, and I always try to use SI units where practically possible. So 0.5 would be half a second, for example. Let us buy ultra wides first, says Pixie. He's quite right. Yeah. So I went away and started creating some functions, and these are actually not that relevant. We'll have a look at the interesting one first. We'll work it backwards because we started having a bit of a discussion on the Discord server as to why why potentially there's some confusion with some of the methods that I'm using. Let's have a look at the most obvious one first. Get sequence length. Right, so what if you wanted to know what's the overall duration of the sequence? You've now not got a vector of anything. You've just got this map of arbitrary things injected into it. Well, you know that the last thing injected into the map... Oh, I should point out maps are sorted. I must mention that they are ordered, so that's quite important. So we know that the last thing in the map is at time t, which would be sort of the end of the sequence. So to get to the last thing of the map, I'm looking at the end of the map structure, and I'm taking the value before that, because end doesn't actually represent anything in standard container speak. So we take the one previous to it, and that'll be the last element in the map. The two types of data that come out of this are the time. That's usually because when you interrogate a map, you get a standard pair, and a pair consists of first and second. Now, the first element is the time, the second element is the data. In this case, it's a keyframe of our polygons. We're getting to the crux of it here. Very wordy is a strong argument. Oh, Magetsu. Yep, you're not first as a result, you see. Put Lara down for a minute. And disable those mods. I know you. Yeah, as Tomb Raider Remastered Trilogy is on my radar to purchase because I was a huge fan of the original games when they came out, but what just keeps putting me off is every review I read just complains about how clumsy the controls are, and I worry about that. However, Magetsu has assured me it's fine. Alice, hello. Yes, we're doing some geometry stuff tonight. Well, we're actually doing some map stuff tonight, not cartography maps. Now, let's have a look at the core function here. It's, you know, we should do some fun. Let's show something running first. So I've modified the rest of the application. It's got a bit more to it now, but the important bit I've labeled here so we can all see is this. This is our polymorph. We've got a scrubber you'll see on the screen now. Scrubber is like the thing that you drag along when you're editing video or audio or something. So we've got that representing time. We're going to say to the polymorph, give me your polygon at this time. Now, I've added a few bells and whistles to make this a bit posher. And right at the moment, when we get data at time, we also pass in a mystery function. We'll have a look at that too. But let's just run it and see what happens. Maps are not contiguous in memory. Won't it be slower than a vector as it's forever following pointers to the next value? Not necessarily, no. Because maps can use buckets and clever technologies to actually work out where it needs to go without having to follow any pointers. That's fundamentally why a hash map is a useful data structure. They're a bit more complicated when it is a sorted map, I should point out. But I don't think it'll actually pay a performance penalty. Given that most animations are not going to consist of hundreds of frames, it's just a few. We're only using the memory we actually need, plus or minus a little bit. So this is the application I've got at the moment, and here is a scrubber at the bottom. You can see I can pick it up and scrub, right? But nothing changes because we've only got 2 keyframes in our polymorph. The first one is, you see on the scrubber, I've even color-coded them. Maybe it doesn't come through on the stream, but the yellow lines represent keyframes. And check this out, the cursor snaps to keyframes. Joink, see? Isn't that really nice, huh? So most of the code you've just seen on the screen is actually fluff to make that sort of stuff happen. And when you're at a keyframe, you can see the vertices of the fan shape. I've still only got support for the one fan at the moment. Now what I'm going to do is drag the scrubber to a certain point in time and press the space key. That inserts a keyframe, and we'll have a look at that mechanism in a minute. The last time finder wasn't far off being generic if he wants to allow vectors to. Exactly. The actual implementation behind the scenes of this isn't that relevant. It's just I wanted something that was easier to work with. If you do end up using something like this in a game, you can implement how it does it however you want. I suppose the whole point is to get to a point where the data is stored. What is this? An image editor. This is a breakaway tool from the overall 2D editor that I'm currently creating, just to allow us to focus without distraction on the rest of the GUI stuff. So I've added a keyframe. There it is. You can see it's another yellow light. And look, check it out. Check it out. Oh, yep, snap. Doink. That's really nice. So we can snap to that keyframe. Now I can then go. Oh, I have to let go of the cursor. There we are. I can then go and edit the vertices at this keyframe. So let's go and stick these out here. We'll just change the shape of our polygon. And now if we start to scrub, we can see we get this very simple linear interpolation between those 2 keyframes. Now 3 keyframes. We can even, now we've got sort of, we're in between now in an interpolation. We can snap that off by inserting a keyframe and edit the geometry even more. Do some sort of micro editing there. So now at the start, we go to that keyframe, we then go to that one, and go back to the start again. Right, so as you can see, it's kind of handling it for us. Now our map structure will consist of 4 things. This keyframe, this keyframe, this keyframe, and this keyframe. And I don't even know what times these are. That's approximately 0.5, that'll be approximately 0.4. What happens if you try and drag lines over each other? That's an interesting question. Because this is a fan data structure, you do get awkward things going on. See, look at that. Right? Isn't that weird? So you might actually want a different polygon type. I think we discussed that last time. We did a bit of a refresher. I think it was somebody asked, and we did a refresher on polygon data types. Can you set easings for those ranges? Ah, well, you'll see. We're getting there. We're getting there. No, it's quite interesting because this is a fan structure. This is the sort of the pivot of the fan, the middle one. That's why it sort of sticks out on its own. These I should probably try and draw the lines in between the vertices so you can actually see what's going on. But fans do have sort of some limitations. Can't go backwards because every point basically stems from this middle point. That's by the by. Don't think of that as a limitation because it's very easy to change the underlying polygon type. Well, you don't have to look at the last one, but yeah, we have sort of continued from where we left off. So, I wanted to sort of show we've got this scrubber ability, we've got the ability to then sort of change and edit vertices in the map. So let's just go and crush all of these up. One last little example. There we go, whatever. I've just destroyed it, doesn't matter. Yoink. And it's just sort of nicely all folding up and interpolating amongst itself. Now, you may also recall we can interpolate colours as well. That happens quite nicely too, because I haven't coded a mechanism yet to sort of set the colours manually in the same way. Right, so that's what this application is doing, and we'll go and have a quick look. Let's go and see where we're setting up the data for the polygon at the beginning. So I obviously can tell it's a bit of a circle that's being made up. Does that use lerp? It does use a lerp. Well, okay, we'll go and have a quick look at what is happening then. We've got to not jump around because of every single question. I'm going to focus on how we're constructing the data because that's the interesting bit. So now, because I'm representing the map, using the time as a key value pair, I can literally just say map frames the time dot data and then insert some data at that time. We had a constraint that once the first frame has been specified, all subsequent frames must contain the same number of vertices. That's not an uncommon constraint. That's simply because in order to do the interpolations between the vertices, you need to interpolate between corresponding vertices. And if they start moving around or changing in numbers, the interpolations can become quite undefined. So I create a circle by iterating through points with my lovely equation here, and just sine and cos my way to it, to generating a circle. Nothing particularly clever there. I do it twice because I'm creating one at time 0 and one at time 10. But let's just have a look at the stuff down here. So I'm going to take out, I'm just going to comment those out for now, and instead bring in some of the more manual code. And we'll bring in that one and this one for the time being. So these have some colors associated with them. So I'm going to insert a frame of just 4 vertices at time 0 and a frame at time 10. Let's see what happens. Yeah, it's using lerp. But the only reason I'm not jumping on it straight away is we are going to talk about the lerp because there's some interesting things to discuss. What, have I won? Did I click? Did it work? Is it built? What's going on? That's built. Okay, good. So this was the shape that we were playing with last time. Same thing. So I'm going to drag the scrubber. You can see there's the 2 shapes. One. And then I've also increased the resolution of the application. That's why the shape has got a bit smaller. So let's stick one in the middle just to prove a point. We'll drag you over there, drag you over there, you over there, and come on, drag that over there. So there's our first frame, second frame, and third frame was back up there again. And you can see it's actually lerping the colours this time. So it's a bit visually a bit nicer. But what's really nice is you can specify the time directly. So you can, as you can see here, I've got a frame at 8 seconds in. And if we wanted an awkward one like this one at 5.534356 seconds in, that's fine too. So you just directly index the map with the time that you want. This is advantageous because you can easily turn your sort of your ticker, the thing. In my case, it's the scrubber along the bottom, but in you're playing back in your animation, you might be accumulating frame time, and you just simply sample the map at that location. It's also very easy to insert frames wherever you want, and it's easy to sort of relocate frames around by changing key values. You may need to extract them and reinsert them back into the map, but it's that's not a difficult thing to do. And we can see that I'm doing this. This is the code that handles the scrubber. Oh, it looks complicated because it's really just it's trying to be nice in terms of screen dimensions. So it's always going to look along the bottom edge of the screen. So really, this is normalizing the mouse cursor into the time domain of the polymorph sequence. And this is the snapping code. It's actually not that complicated. Basically, I go through all of the frames in the polymorph, and I just look to see how close I am to one of the key values of those frames. If I'm within a certain distance, in this case 0.1 of a second, snap to it. And so that's implemented the snapping. And it's nice because the whole thing's dynamic. I'm not creating sort of any iterating code of my own. I'm just using the bog standard map. If your time type doesn't really represent something meaningful, it's not really seconds, why not using size t and lit? Well, you could use whatever you want. It doesn't have to be. Sounds more computationally friendly. Does it? Well, does it sound more friendly to start thinking in terms of animation as a value between 0 and 2 to the power of 64 minus 1? Or is it better that, well, this guy's walking animation is half a second? Or there's different levels of friendliness. And fundamentally, however the hash map implements double, and I don't know, but I suspect it's not doing it numerically. It probably is doing it just using the bits of the double. Although maybe it is doing something numeric because it is sorted. So it doesn't really matter how you represent time in your system as long as you're consistent with it. And you don't lose values when limiting yourself to 0 to 10 seconds. Well, I don't think I'm going to have 2 to the power of 64 keyframes. Exactly, yeah, as long as the floating point inaccuracy is below a frame, does it matter? And I mean, I've done this as a silly example just to see did it work. Nobody's ever going to specify times like this for an animation sequence, not in reality. And so you would normally clamp it to perhaps 1/60th if you are interested in per frame level accuracy, which of course is nothing like that level of precision. Could you get a program to recognize and name standard geometric shapes? Interesting. I used to set that as a coursework for some students. And we would do it we wanted to do coin identification. How do you think you'd go about identifying coins? Probably easier to allow changing the total animation time if you need to. Well, that's, by working in terms of time, the one major advantage is, of course, you can then scale time. So if you wanted your animation to be faster or slower, or indeed not linear, you've got those sort of options without having to think about the computational overhead. Neural networks, size. Size isn't actually a very good measure. It's an important one. Shape. Well, that's what you're asking, Alice. So yeah, we don't mention the N words here. Machine vision. Yes, thank you, Alice. Yeah, it wouldn't. The computer's not just going to know. It's going to have to employ some algorithms to work these things out. The way I approached it is, firstly, you can do some image segmentation to at least identify coin and not coin. Imagine a whole load of coins going past a camera. Then one way to work it out is to find the centroid of the blobs that you're left with, and then do a peripheral walk around the edge of the blob, recording the radial length from the edge to the centroid of that blob, and then you end up with sort of a peak. Peak per point. Now in the UK we've got some coins that are sort of hexagonal and heptagonal. Let's say you're working with squares and triangles and other interesting shapes. They all have fairly unique circumference profiles with respect to the radius. And from that you can actually easily classify other things. So it was a good exercise. All euro coins are disc shaped. Yeah, but euro coins is like toy money, isn't it? So on that note, we'll move on. So yes, we can just sort of interact with time quite nicely. And once we've got a particular scrub time, oh look at this! I'm using the Geometry 2D library to actually check if my mouse cursor and things is within the rectangle of the scrubber. The important bit is we can then specify that time to our polymorph structure. And let's go and have a look at what it does, because it's with the interesting bit. Polymorph structure. Get data at time. So this was the function. Now, we're going to come back to the lambda function bit in a minute, but right now we can assume it's just linear. Get data at time, and we provide in a time. So I created then a function. My first approach to this was to use two functions which are provided by map, called lower bound and upper bound. And this caused a bit of dispute because I got it wrong. Hands up, it was my fault. And when I'm wrong, the first person usually to point out that I'm wrong is Danderstein, and he did. And so I sort of just thought about it for a minute. I thought, I don't think I'm wrong, but I don't think that the usage of these functions is actually very clear. So what are they supposed to do, lower bound and upper bound? My understanding was that lower bound finds the key below the value you're asking for, and that upper bound would find the next key after the value you're asking for. And this is very useful if you think in terms of time. So maybe I don't have a particular frame at 0.5 seconds, but I do have one at 0.4 and I do have one at 0.6. By working out what those are, I can then interpolate between the two. And it turns out that actually that's not what they do. And some of the mathematicians got involved and said, no, you're absolutely wrong, Jared, because boundaries and limits don't mean the same thing. And it is really, my argument is that you've got two functions here. One does what I expect it to do, but the other one doesn't. However, my argument is that these are named symmetrically, but they behave asymmetrically, and I don't think that's a very good design decision of whoever decided to add that into the standard library. It is a bit misleading. These down here. So this is in C++. If you have a pointer, which is sort of a memory address, or in this case, it's a bit more complicated. It's an iterator. You access the data through the pointer using the arrow syntax. That's a C++ thing. So yeah, be careful thinking lower bound and upper bound do what you do, and this is what they actually do. So lower bound returns a key greater than or equal to d time, and upper bound returns the key greater than d time. And I can't see the virtue necessarily in what that's for. It's to do with finding the boundary for the right open set the value is in, which can't be symmetric by its nature. Why? If I have a set of integer, I'm not a mathematician, so I know, Charnel, you are. So give me the benefit of the doubt here. If I have a set of integers, for example, and I wanted to get the lower bound of 5.5, why is that 6? Unknown programmer boy. Hello, you're... Oh, thank you. I'm about to get my ass handed to me by mathematicians that are going to go, no, it's maths, not code. But we'll see. Anyway, it occurred to me that perhaps, I'm not going to argue. The mathematicians, they're normally right about such things, but I just then studied to sort of, failed to understand the virtue of this pairing of functions, and it went on to then go and create what I actually needed, because upper bound actually behaves the way I expect it to. And now I know how lower bound behaves, I should probably use that because it'll be slightly more accurate. So what I do, it rounds up in the code. Well, you kind of expect it to, but because it gets more complicated because the maps might not necessarily be using the sort of these continuous real numbers. They could be using any other object that's defined, as long as there's some definition of one object being larger than another. At which point I get that the sort of the settiness of all of this starts to come into play. Lower bound is keys is less than or equal. No, that's the point. That's my argument. It's not, and that's what was confusing me, channel. It's not. It's greater than or equal to d time, or greater than d time. At least that was after my head was done in by it all. That was what I took away from it. Is it a floating point pretending to be an integer? Technically, all floating points, I guess, are integers. But not necessarily in this instance. You've got to understand that the bit pattern that represents the key value in this map could be being interpreted in 1,000,001 different ways by the map data structure. Well, you've got to have two parts of the ball series. Everybody on the internet laughs at my balls. It's no good. I don't know how to feel about that. All right, so I went away and created the function that's actually needed. I called it get bounding keyframes, and you pass in a time. So this goes away and does what it needs to do. And we'll go and have a look at what this does. It says go and get to the upper bound. When we go and have a look at the upper bound, which calls the upper bound function. Now, I don't think we should necessarily be using that, but I am at the moment. And what I do is to check we're not at the end. So I'm kind of at the same time adding in some clamping. It's a bit naughty. So if the upper bound happens to be the beyond the last frame, then make it the last frame. So we clamp it in. Once I've got that upper bound, I can then return a pair of objects. In this case, it is the upper bound and the one immediately preceding the upper bound. However, if the upper bound was the beginning of the range, then I just want to return the upper bound twice. Because if the upper bound is the beginning of the range, then you have to assume the range only has one thing in it. So okay, that's what we're doing here. We're making pairs, and we're returning below all this modern C++ syntax that you're getting thrown at you tonight. Because now we can do something like this, which is quite nice, I think. We can get the lower bound and the upper bound immediately sort of decomposed from the pair into usable variable types. In this case, they are iterators into our map. If they are the same, there's no need to do any interpolation. You just return the data. If they are not the same, then we can look at the time that we passed in and look at the difference of the key values, which is the times of the upper bound and lower bound frame, and we can work out in a normalized time space between those two frames where we are and how to do the interpolation. And this is the exciting point because we call this interp function, which was passed into the getDataAtTime function. Are you still with me? So we're not doing any searching, we're not doing any accumulations, we're not doing any sort of interesting while loops or breaking away because we've stored things in a vector. We can just use the hash map to do its thing. And there's an analogy here to spatial grid maps. So when I did my quad tree video, quite a lot of people responded, well, you know, quad tree's a bit old hat. There are sort of these sort of spatially hashed trees instead. And you can consider this approach being the same as a one-dimensional instance of that sort of data structure. It allows us to search for the data much quicker, and it actually paid off. I did actually profile the two versions side by side. I've not got the original version, unfortunately, anymore, but I gained about at a lower resolution, I gained about 300 frames per second doing it this way rather than doing the accumulations, which that was only over like 5 or so keyframes, but it made enough difference. Quoting the standard on lower bound returns the furthermost iterator I. So you're quoting the standard. I was quoting... right, so 300... Well, it was from... This is where it gets a bit silly. It was from about 5,100 to 5,400 frames per second. That was at when it was running it at the lower resolution originally. Now, I thought that was actually significant enough to to proceed with this, and given that it seemed to behave faster, it's got a slightly larger memory footprint, but I honestly don't care, and it's easier to use, then they're all wins for me. So that's why I'm sticking with this. Yeah, will you make videos related to socket programming or network learning of AI? I won't be doing any AI videos. I am not interested in AI. It is the singular most boring topic of anything. So, my keyframe structure, right, let's go and have a look at us using it again. The important bit, we can get the data at time. This is the time of the scrubber. And we know that we receive a polygon, and I can go away and then just draw the polygon. So I actually do that down here. That's drawing the scrubber. Where do I actually draw the polygon? Oh, there it is, draw polygon decal. So none of this actually changed from the previous video. We get our polygon, we decompose it into things that can actually be drawn by sort of pixel game engine in the back end. And this one's quite interesting. If we wanted to insert the keyframe, right? So this all now becomes very easy to do indeed. Once I've got my polygon at that particular location, I press the spacebar. All I need to do is insert at that scrub time the polygon, and it immediately creates the new keyframe. So suddenly things started to code themselves, and I was getting all of these byproducts of using this data structure for free, basically, which is usually a good sign. In my head, if things start writing themselves, I'm usually on the right track. Yeah, there probably was. Never say never, right? And it doesn't necessarily mean that the videos... You'll notice most of my multi-part videos are never released sort of one after the other. They're usually scattered all over the place. The Lewis series had videos with almost 2 years in between. The platforming one, I think, had like 4 years between them. The networking one, though, I did sort of get interrupted by becoming a father. Yeah, so I think if you have a look on... Sorry, Standard Int, jumping back to what you've just posted. If you have a look on CPP Ref, which is the good one, I can never remember. Not the one everybody doesn't like, the good one. The documentation isn't quite as clear. I actually posted some links to it in Lang CPP on Sunday. Yeah, CPP Ref is what I usually... It's my go-to one anyway. You see, if inserting a value into a sorted list, give the boundaries of where that value could be inserted. It's just, this is it, right? We've now, just in this chat alone, a couple of people that I know their stuff. It's not mega clear what's supposed to be going on. And I just couldn't understand the virtue of it. I'm fine, I'm happy. If that's what the functions do, I'm not going to argue. If that's what the standard says they should do, that's fine. But I couldn't really understand how I would then go and use them sensibly to achieve what I think that they're trying to do. Yeah, you're probably right. I ended up doing what I needed to do in the end. I mistakenly used upper bound. And I think I should be, in my get next week keyframe, I think this should actually be lower bound, simply because if I search specifically for a time that exists as a keyframe already, perhaps the equality aspect is actually more useful to me there. It doesn't seem to have thrown up as being a problem yet, but it did. It's sort of raising, there's a flag being raised somewhere in my brain that might be a problem. So once we've got our polygon, this is the function, get data at time. We pass in our interpolation function. And this is where things got a little bit fun. So the basic interpolation function I've just called morph. Here, this was exactly the same as the one that I showed last week. Pass in the two polygons, pass in a value between 0 and 1, and it goes away and creates a new polygon by interpolating all of the values. So you can see it's using a lerp for the values there, and it's using a lerp for the color values too. We also said we may want to extend this to texture coordinates and possibly other parameters associated with the vertices. Then I went to one of my favorite websites called easings.net. Now, if you've not used this website, it's a really nice way to look at something called sort of tweens or interpolations with different interesting properties. And it gives you a bunch to choose from, and you put your cursor over it and you can see how it should behave. So this one starts off slow and gets really quick. This is a fun one, this ease in out elastic. It's got a bit of a bounce to it, and you can see it actually goes beyond the ranges of the polygons. Now, this is all very well and good, and the nice thing is you can actually click on the one you want, and it gives you some code in some unknown language, but it was easy enough to sort of transfer over to what it needed to be. You've got to scroll past all the web drivel to get to the relevant bit at the bottom. However, I was thinking, oh, it would be great. It's open source. I'll go to the website and I'll I'll just go and implement all of the functions and provide them in some neatly packaged namespace for C++. But unfortunately, they have a license which isn't necessarily one I would like to use. So even though this is a great resource, and for the example today, I have taken one of the interpolations directly. Going forward, I'm going to have to just do these manually. Did you know how I can use CPP code with Python scripts? I think you can just create a library of your C++ functions and link them in. Oh, that's fine. Might be something we can use. The only reason GPL3, and I might be misunderstanding this, but as I understand it, you've got to provide your source code. Now, obviously, I do, right? My code is always sort of open source stuff, but I don't like being made to provide it. I feel that's a bit different. James, hello. Zen artist. Yeah, not too bad. Not too bad. Back on the old CodeZone. That's good. Well, yeah, exactly. So I just thought, I wonder if that's an oversight from the creators of that repo. Anyway, I did go and take I've credited it here, but after today we'll get rid of this or we'll change it because I don't actually like the code. So I took their code directly, made it into C++. There it all is, all of the functions. Because this is a function and our get frame at time call down here, there we go. There it is. Allows you to specify a specific function. You can now change the nature of that interpolation. Let's have a look. OLC3 is the best license. So here are our keyframes. If we now drag our scrubber, they go boing, boing, boing. You see, you get sort of a zap. Quite nice, huh? So what I'll do is I'll put back in the I'll get rid of the little triangles and put back in the circles, something with a bit more interesting stuff. Comment those out. Bring that back in. Yeah, not many Python programmers tend to find their way to me. My understanding, though, is every function in Python fundamentally is C++ behind the scenes. Right? So I think you just, I guess you compile a DLL or something with your C++ code, and presumably Python has some bindings or method of binding directly to it. Right, let's run that. So there we go. So we've got our circles back. So what I'll do is I'll drag the scrubber over to the middle, and we'll place a keyframe, which, as you can see, is really easy to do. There's nothing special, and we'll make it sort of go bang like that. Make it a bit Sanic. And if we drag the scrubber back, boink, boing, boink, boing. That's rather pleasing. I mean, that might be something that we want to start including in our polymorph, is perhaps an index into a morphing function. some sort of easing function like that. You can actually see it changes the colors as well, because if you recall on the easings website, this specific function that we're looking at, this one, it goes slightly below and slightly above the sort of the two different states. Well, because I've not got the magenta color fully saturated, it does actually allow some headroom for the magenta to go a bit brighter, and it sort of gives it that nice little visual pop, which I quite like. We'll go back to that one. Now, again, if we look at the easings website, we can see that really the transition is very short, and it happens in between the two keyframes. So you can envisage there's a keyframe here and a keyframe here. That's why they sort of stay dormant until the scrubber gets towards the middle, and then it does its thing, and then it settles back down again. So we can add in another one. Let's really mess it up. We'll go inwards now. Don't forget this is a fan, so we'll make it start to look all a bit crazy. I was making them sort of deliberately messed up because it's quite nice to see how it all unfolds itself. And yeah, so let's go and drag that so it goes yoink, woomph. I like that. Hang on, catch up with some things. Will you make this a stream or video on YouTube? So all of the streams go on my second channel, JavidX9 Extra. We're up to 66, so yeah, these will be going up. Will this become a specific video? Maybe. I have got a video coming up about triangulation, which is probably going to be sort of the next stages with this. How do we triangulate user-drawn models into sufficient polygon data sets in the background? Because right now we're limited to this fan data set, which is a little bit constraining. Excuse me. So I'm just I keep thinking I see some like frame corruption, but it's not. It's just going very fast. That's quite nice. And of course we can go away and create all sorts of easing functions to add in. Whether that makes them easier to work with, I don't know. Because I think that this one would be quite difficult to animate with, because the animation's kind of included for you. So maybe it's a shortcut one if something exploded or you wanted something to wobble. This is quite a nice way to do it. Let's add another keyframe here. Let's stretch it out to being something long and thin, maybe. We'll keep that over there. We've got some sort of anchor. See, I'm no animator at all. Stick that one there and that one there. That's the pivot point of the fan. So that's why you get that sort of interesting additional lines there. I like that. You can hear it, can't you? I think it's made out of like blancmange. Once a point goes inside, it'll make the transition look like it stopped prematurely. Once a point goes inside, so let's snap to a key point. So you mean like if yeah, you mean sort of like that. That's a point that's gone inside. Well, I guess you just don't see that detail. I suppose with the fan shape, there are sort of other things you could do. You can sort of break the nature of the fan shape by doing that. Yoink. Because it overshoots, that's what gives it this sort of wobbly effect. But it overshoots sensibly. So I'd say that it's actually not sort of just throwing vertices all over the place. It is sort of interpolating them along the path it should go. Yeah. So really the takeaway message from this is having a good think about the data type that we're using to store the frame data. has made me think about all sorts of things now. If you were doing video editing, I'd probably do something like similar. If I think using a map just makes a lot of sense. It's made the coding much simpler. It's made the interrogation of the data structure much simpler. It's then made the editing of the data structure much simpler. It's all just fallen into place, and it increased performance. So it's a win-win all round for this one. And the fact that I can just now directly work with time, directly with the data structure as well. Yeah, it was worth converting the code over. So what's next? Well, I want to try and get some of this back into the editor. I might add some more features to this simplistic editor ability to maybe save. Ooh. Johnny G63, thank you very much. Late as usual. Oh. Thank you very much for the subscription there. Yeah, we're not too bad. We're almost at the end though. So sorry about that. We had a good one today looking at the interpolation and changing the fundamental data structure I'm using behind the scenes. So what I was saying is what we're going to be doing next is I don't necessarily want to shove it in the editor just yet. I think I will flesh out perhaps serializing this data structure so we can actually save the files and have a look at editing the fundamental polygon type. The other side to this is one polymorph on its own is just a coloured polygon. Real sort of animated objects, such as a character running, is a collection of all sorts of things, including multiple layers of interrelated polymorphs. So maybe it's time to start thinking about having multiple polymorphs in one application. And somehow defining the relationship between the two. Now, some of you may recall in the last episode that relationship between the two can also be morphic. So the nature of that relationship can also be changed over time. And that becomes quite a complicated thing to build tooling for, but ultimately that is the goal of this editor, to create tooling to allow us to animate in this particular way, and then export all of this in a way that something like the Pixel game engine can read very easily. That's the goal. We're almost there. Maybe it's just worth quickly hacking in another easing. Shall we pick one? Let's, well, we've got a few minutes left. Which one do we like? So on easings.net, I'll drop the link. If you all jump onto this site, go and choose one, which you think we should try and implement and see what happens. I know you're going to pick sort of the really chaotic, awkward ones, but they may end up not looking that different to what we've already got. Maybe something that's not sort of with a rapid transition in between. Ease in, out, circ. Ease out, bounce. Bounce. Ease out, bounce. That one. Okay, let's have a look at ease out, bounce. We'll go and have a look at this bit of code. It's got some magic numbers in it. And let's go and have a look. Let's go and create another function. So I'll smash that code there. I'm going to steal this bit. And I'm going to stick a thing in here. Right. So this was ease out, bounce. Ease out, bounce. Now, you'll notice actually in my morphing function here for the elastic one, I actually used the original one to do the final interpolation, because actually all this function does is translate that normalized value into a different normalized value. So that was quite a nice saving there. Right, let's just C++ify this. Those x is sort of our input value. They need to become t's. And it's not return. We want sort of a double new t. Right, so these x's become t's. Oh, do you know what? Just to keep this really simple, let's just go and change that up there. X and returns become nt equals nt equals. What's this? Oh, it must be a modifiable value. Oh dear. Oh, we're going to have to put t in anyway. Double t. Oh, do I? Do I? I don't. I do. I do. Double. What we're doing? Double x equals t. Right. T up there. New t is that. X is fine. X. Yeah, okay. And then we can return the same thing. Okay. P1, P2, NT. I can't easily just unconst the x because the function prototype is actually something that's passed around the data structure later on. So you'll see the get, it actually includes the consts as part of this function prototype. I don't want to change that. Right, that might work. It's whether I'd see. The thing is, does JavaScript behave in the way that I expect it to behave? But I guess it doesn't matter in this instance because once it's done one of these, it just goes straight away. It's basically returned, so it doesn't matter if it actually modifies the x value. Just make you think: why does it need to modify the x value there, or does it then? Yeah, there's all sorts going on in this. Anyway, let's go and have a look at what that looks like. So ease out bounce. We go down to the important bit. And hopefully if it compiles, we should start to see a slightly different behavior. It compiled. It's reassuring. So there's our starting frame and our end frame. We'll stick one in the middle. And we'll make it spiky again. And see what happens. So, boing. Yeah, I guess it kind of does, doesn't it? So it sort of eases out. But everything is biased towards the second frame rather than the first frame this time. First frame just naturally goes out, bounces, becomes. Let's stick something in here. Let's make this all very small, except for that side of it. Boing. Doing. Yeah, I don't know if visually that one's quite as nice as the other one. You've not let that through a code review. Yeah, there's it's not great, is it? Right. Right, that's enough for you to tell my cough is already starting to come back now. So I think that's enough for tonight. So I've changed it over to a map and it's starting to look like, it looks like I know what I'm doing when I've got code like this in it now. Some interesting debate to have there, whether the upper bound and lower bound stuff is actually doing what it should be doing rather than what we think it's doing. Good stuff. Right, until then, take care. Thank you for watching. I'm looking for the camera. There it is. Thank you for watching and I'll see you next time. Bye-bye.